Okay, this is LSAT PrepTest 21, Section 1, questions 7 through 11, the second logic game of this test. So let's go ahead and take a look. A worker would install colored light bulbs into a billboard equipped with exactly 3 light sockets, which are labeled lights 1, 2, and 3. Okay, so it's 3 light sockets, 1, 2, and 3. Fantastic. The worker has 3 green bulbs, 3 purple bulbs, and 3 yellow bulbs. Okay, so basically what we're told is that there's green, purple, and yellow, and that we can fill all these slots with 3 of each of these colors. So we have plenty of light bulbs, is the point. Okay. Selection of bulbs for the socket is governed by the following conditions. Okay, so when light 1 is purple, light 2 must be yellow. So when 1 is purple, that implies 2 is yellow. Second rule, when light 2 is green, light 1 must be green. Okay. And then whenever light 3 is either purple or yellow, 3P or 3Y, that implies light 2 is purple, 2 purple. Okay, so this rule in particular stands out to me as something that would be much better served as its contrapositive. Right, so let's actually just write that out. So if 2 is not purple, that means 3 can't be purple and 3 can't be yellow. Or what does this mean? If it can't be purple, can't be yellow, 3 must be green. Right? So we can even just rewrite this entire statement as 2P/ implies 3G. So actually we just leave it like that. That's probably fine. Okay, the rest of these obviously we can take contrapositives of as well, so we might as well just do it and save ourselves the hassle later on. All right, so if the second bulb isn't yellow, the first bulb isn't purple. If the first bulb isn't green, the second bulb isn't green. Okay, so there's no deductions to be made here, not really, right? Because you have 2y, 1p, or 1p, 2y, 2 being green, 1 being green, and like all these are just sort of unrelated conditional statements. Okay, so for forgetting about that, let's just go ahead and draw some lines. Separate this off from the rest of our paper, or virtual paper anyway, and then we'll go ahead and look at some questions. Okay, that's a little ugly, but it'll do. Okay, so question 7, your typical acceptability question. So it's asking you which of the following can be an accurate list of colors for lights 1, 2, and 3. So green, green, yellow, purple, green, green, purple, purple, green, yellow, purple, green, yellow, yellow, yellow. Okay, so let's just go through with these rules and figure out what we can. So if the first one's purple, that's these two, right? 2 must be yellow. Purple, green, purple, purple. So neither of those can be it. How about this one? If the second one's green, the first one's going to be green. Okay, so this one's good, and these two aren't. Right? This rule just doesn't apply to these other two. So we started out pretty strong, and now we've lost steam a bit. Okay, so this third one. If the third one is purple, or the third one is yellow, the second one must be purple. So here the third one is yellow, second one's not purple though, so that can't be it. Right here the third one is yellow, but the second one's not purple, so that can't really be it either. Okay, so it turns out answer choice D is the correct answer to this question. Right. I mean, and actually, now that I think about it, when I say that there aren't any inferences, I mean there aren't anything that you can like smash together. But like this, for example, tells you that you can't ever have 3 yellows in a row, right? Because if 3 is yellow, 2 must be purple, right? So just little things like that maybe you don't necessarily explicitly think about up front, but then like by going through these rules, they just kind of you figure it out as you go. Okay, so answer choice A, number 8. If light 1 is yellow, then any of the following could be true except. Okay, so yellow, blank, blank, right? Okay, so what are the rules that we have governing this first slot? So if the first slot's purple, second's yellow, but the first slot isn't purple, so there's nothing we can do about it, right? But then how about this rule, this contrapositive rule? If the first slot is not green, the second slot also cannot be green, right? So that's just the contrapositive of rule number 2. And that's the only other thing we know about this first slot, right? Where we have a sufficient condition having to do with the first slot. The first slot's not green, the second slot can't be green either, right? So this is it. This has to be the answer. And so looking at the answer choices, answer choice A just immediately sticks out, right? Light 2 can under no circumstances be green because light 1 is not green. Answer choice A is your correct answer there. Because if this was a test, you would just keep going. But seeing as this is a tutorial, we might as well take a look at the rest of them as well, right? So answer choice B, light 2 is purple, right? That doesn't trigger any rules, right? Like we have this one if 2 isn't purple, but that doesn't trigger any rules otherwise, so that's fine. Answer choice C, light 3 is green, 3G. There's no 3G here in a sufficient condition, right? Which means that none of these rules fire. How about 3 being purple? Means that 2 must be purple. Well, that's fine. Yellow, purple, purple, right? Okay, great. How about light 3 being yellow? Once again, all we know is that that means that this has to be purple. You can have yellow, purple, yellow, right? So we just sort of really quickly run through all of these and convince ourselves that answer choice A is in fact the correct answer. Okay, moving on to question 9. Question 9 asks us, there's exactly one possible color sequence of the 3 lights if which one of the following is true. Okay, so basically what it's asking us is, if one of these things is true, that means you should be able to tell me what the other 2 colors of lights are, 100%, no questions asked. Okay, so I mean, let's just go ahead and try, right? If light 1 is purple, what do we know? Well, if light 1 is purple, light 2 is yellow. Great. Okay, if 2 is green, that rule doesn't trigger. If 3 is purple or yellow, then 2 is purple. This rule doesn't trigger the forward way, but it does trigger the backward way, right? If the second slot is not purple, and here it's not, then the third slot must be green, right? So immediately answer choice A looks very, very good. We know for sure that if P is 1, it's got to be PYG. Okay? Looking at the rest of these really quickly, right? Light 2 is purple, so what if light 2 is purple? Light 2 being purple means that light 1 can't be purple, but then it could still be green or yellow. And so we have no idea which one is which. So answer choice B is just not going to be correct. How about C? Light 2 is yellow, blank, yellow, blank. Well, if light 2 is yellow, what does that mean? It means that light 2 is not purple, which means that 3 must be green. But then what does that tell us about this light, right? It could be anything. It could be green, it could be purple, or it could be yellow, right? We just have no idea what this slot is. So once again, answer choice C is not correct. How about D? Light 3 is purple, 1, 2, 3. This third one's purple. If the third one's purple, that means the second one's purple. But then we don't know anything about this first slot, right? It could be green, it could be yellow, it could be purple. We just have no clue. So, continues to be wrong. And how about E? Light 3 is yellow. Light 3 is yellow, means the same thing. Light 2 is purple, and again means the same thing. We have no idea what this first slot is. So answer choice E is also wrong. Turns out answer choice A is the correct answer to this question. So, great. How about question 10? If no green bulbs are selected, exactly how many different possible color sequences of the 3 lights? Okay, so now we only have yellow and purple bulbs, right? So there's so I mean, I guess you can start in terms of this last slot, because we have this rule saying that if the third slot is purple or yellow, in this case it has to be, right? Then the second slot must be purple. So there's 2 ways that this can happen. If the third slot is purple, second slot must be purple. Third slot is yellow, second slot must also be yellow, right? And so here's the question. Given that the second slot is purple, what else do we know? Well, if the second slot is purple, we know the first one can't be, is not yellow, meaning the first one can't be purple, which means if we only have these 2 colors, if it's not purple, must be yellow. Number 1, number 2. There's only 2 ways that we can possibly do this, and that's answer choice B. Finally, 11. If no 2 lights are assigned light bulbs that are the same color as each other, which of the following could be true? Okay, so now all 3 of them have to be different. Right, okay, so let's go ahead and write these out. So if so answer choice A says that if light number 1 is green, light number 2 is purple, that means this third light has to be yellow, right? Because they all have to be different colors from each other. Can that work? Yeah, 1 is not purple, so we don't trigger this rule. 2 is not green, so we don't trigger. 3 is yellow, but that means second is purple. That's great, that's fine, right? And none of these contrapositives trigger either. Okay, so answer choice A looks like it could be pretty good. How about B? Light 1 is green, light 2 is yellow, meaning light 3 is purple. Well, if light 3 is purple, light 2 has to be purple. So there's no way answer choice B is going to be correct. Answer choice C, light 1 is purple, and light 3 is yellow. If light 3 is yellow, then light 2 has to be yellow. We can't have 2 of the same color here. Or light 2 has to be purple, rather. We can't have 2 of the same color there. So that's not right. How about D? Light 1 is yellow, and light 2 is green, which means that the last one has got to be purple, except in this case it doesn't even matter, because if light 2 is green, light 1 has to be green. Right? That's this rule right here. So answer choice D is wrong. And then how about E? Light 1 is yellow, and light 3 is purple, meaning that light 2 also has to be yellow, except that that's not possible, because if light 3 is purple, light 2 also has to be purple. So once again, answer choice A is the correct answer to this question. And that's just all the games in this or all the questions in this game. I realize now also that here it actually can't be yellow can't actually go in D and E. So earlier when I said that anybody can go here, I misspoke. It's really just green or purple that can go here, right? But anyway, that's the gist of it, and that's just the logic that leads you to all these conclusions. So that's the game.